2.5 Quadratic Equations. The computer monitor on the left in figure 1 is a 23.6-inch model, and the one on the right is a 27-inch model. Proportionally, the monitors appear very similar. If there is a limited amount of space and we desire the largest monitor possible, how do we decide which one to choose? In this section, we will learn how to solve problems such as this using 4 different methods. Solving quadratic equations by factoring. An equation containing a second-degree polynomial is called a quadratic equation. For example, equations such as 2x squared plus 3x minus 1 equals 0 and x squared minus 4 equals 0 are quadratic equations. They are used in countless ways in the fields of engineering, architecture, finance, biological science, and of course, mathematics. Often, the easiest method of solving a quadratic equation is factoring. Factoring means finding expressions that can be multiplied together to give the expression on one side of the equation. If a quadratic equation can be factored, it is written as a product of linear terms. Solving by factoring depends on the zero product property, which states that if a times b equals 0, then a equals 0 or b equals 0, where a and b are real numbers or algebraic expressions. In other words, if the product of two numbers or two expressions equals 0, then one of the numbers or one of the expressions must equal 0 because 0 multiplied by anything equals 0. Multiplying the factors expands the equation to a string of terms separated by plus or minus signs. So in that sense, the operation of multiplication undoes the operation of factoring. For example, expand the factored expression x minus 2 multiplied by x plus 3 by multiplying the two factors together. X minus 2 multiplied by x plus 3 equals x squared plus 3x minus 2x minus 6 equals x squared plus x minus 6. The product is a quadratic expression. Set equal to 0, x squared plus x minus 6 equals 0, is a quadratic equation. If we were to factor the equation, we would get back the factors we multiplied. The process of factoring a quadratic equation depends on the leading coefficient, whether it is 1 or another integer. We will look at both situations, but first, we want to confirm that the equation is written in standard form. Ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a does not equal 0. The equation x squared plus x minus 6 equals 0 and is in standard form. We can use the zero product property to solve quadratic equations, in which we first have to factor out the greatest common factor, GCF, and for equations that have special factoring formulas as well, such as the difference of squares, both of which we will see later in this section. The zero product property and quadratic equations. The zero product property states, if a multiplied by b equals 0, then a equals 0 or b equals 0, where a and b are real numbers or algebraic expressions. A quadratic equation is an equation containing a second-degree polynomial. For example, ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and if a does not equal 0, it is in standard form. Solving quadratics with a leading coefficient of 1. In the quadratic equation x squared plus x minus 6 equals 0, the leading coefficient, or the coefficient of x squared, is 1. We have one method of factoring quadratic equations in this form. How to? Given a quadratic equation with a leading coefficient of 1, factor it. 1. Find two numbers whose product equals c and whose sum equals b. 2. Use those numbers to write two factors of the form x plus k or x minus k, where k is one of the numbers found in step 1. Use the numbers exactly as they are. In other words, if the two numbers are 1 and negative 2, the factors are x plus 1, x minus 2. And 3, solve using the zero product property by setting each factor equal to 0 and solving for the variable. Example 1. Factoring and solving a quadratic with leading coefficient of 1. Factor and solve the equation x squared plus x minus 6 equals 0. To factor x squared plus x minus 6 equals 0, we look for two numbers whose product equals -6 and whose sum equals 1. Begin by looking at the possible factors of -6. The last pair, 3 multiplied by -2, sums to 1, so these are the numbers. Note that only one pair of numbers will work, then write the factors. X minus 2 multiplied by x plus 3 equals 0. To solve this equation, we use the zero product property. Set each factor equal to 0 and solve. X minus 2 multiplied by x plus 3 equals 0, x minus 2 equals 0, x equals 2, and x plus 3 equals 0, x equals -3. The two solutions are 2 and -3, and we can see how the solutions relate to the graph in figure 2. The solutions are x-intercepts of x squared plus x minus 6 equals 0. Example 2. Solve the quadratic equation by factoring. Solve the quadratic equation by factoring x squared plus 8x plus 15 equals 0. Find two numbers whose product equals 15 and whose sum equals 8 and list the factors of 15. The numbers that add to 8 are 3 and 5. Then write the factors. Set each factor equal to 0 and solve. X plus 3 multiplied by x plus 5 equals 0. X plus 3 equals 0, x equals -3. X plus 5 equals 0, x equals -5. The solutions are -3 and -5. Example 3. Using the zero product property to solve a quadratic equation written as the difference of squares. Solve the difference of squares equation using the zero product property. X squared minus 9 equals 0. Solution. Recognizing that the equation represents the difference of squares, we can write the two factors by taking the square root of each term. Using a minus sign as the operator in one factor and a plus sign as the operator in the other, solve using the zero factor property. X squared minus 9 equals 0, x minus 3 multiplied by x plus 3 equals 0, x minus 3 equals 0, x equals 3, x plus 3 equals 0, x equals -3. The solutions are 3 and -3. Factoring and solving a quadratic equation of higher order. When the leading coefficient is not 1, we factor a quadratic equation using the method called grouping, which requires 4 terms. With the equation in standard form, let's review the grouping procedures. 1. With the quadratic in standard form, ax squared plus bx plus c equals 0, multiply a times c. 2. Find two numbers whose product equals ac and whose sum equals b. 3. Rewrite the equation placing the bx term with two terms using the numbers found in step 1 as coefficients of x. 4. Factor the first two terms and then factor the last two terms, and the expressions in parentheses must be exactly the same to use grouping. 5. Factor out the expression in parentheses, and 6. Set the expressions equal to 0 and solve for the variable. Example 4. Solving a quadratic equation using grouping. Use grouping to factor and solve the quadratic equation. 4x squared plus 15x plus 9 equals 0. Solution. First, multiply AC. 4 times 9 equals 36, then list the factors of 36. The only pair of factors that sums to 15 is 3 plus 12. Rewrite the equation replacing the b terms. 15x with two terms using 3 and 12 as coefficients of x, and factor the first two terms and then factor the last two terms. Solve using the zero product property. The solutions are -3/4 and -3. See figure 3. Example 5. Solving a higher degree quadratic equation by factoring. Solve the equation by factoring -3x cubed minus 5x squared minus 2x equals 0. This equation does not look like a quadratic as the highest power is 3, not 2. Recall that the first thing we want to do when solving any equation is to factor out the GCF, if one exists, and it does here. We can factor out negative x from all of the terms and then proceed with grouping. Negative 3x cubed minus 5x squared minus 2x equals 0. Negative x multiplied by 3x squared plus 5x plus 2 equals 0. Use grouping on the expression in parentheses. Negative x multiplied by 3x squared plus 3x plus 2x plus 2 equals 0. Negative x multiplied by 3x multiplied by x plus 1 plus 2 multiplied by x plus 1 equals 0. Negative x multiplied by 3x plus 2 multiplied by x plus 1 equals 0. Now we use the zero product property and notice that we have three factors. The solutions are 0, negative 2/3, and negative 1. Using the square root property. When there is no linear term in the equation, another method of solving a quadratic equation is by using the square root property, in which we isolate the x squared term and take the square root of the number on the other side of the equal sign. Keep in mind that sometimes we may have to manipulate the equation to isolate the x squared term so that the square root property can be used. The square root property with the x squared term isolated, the square root property states that if x squared equals x, if x squared equals k, then x equals plus or minus the square root of k, where k is a non-zero real number. How to? Given a quadratic equation with an x squared term but no x term, use the square root property to solve it. 1. Isolate the x squared term on one side of the equal sign. 2. Take the square root of both sides of the equation, putting a plus or minus sign before the expression on the side opposite the square term. And 3. Simplify the numbers on the side with a plus or minus sign. Example 6. Solving a simple quadratic equation using the square root property. Solve the quadratic using the square root property x squared equals 8. Solution. Take the square root of both sides and then simplify the radical. Remember to use a plus or minus sign before the radical symbol. X squared equals 8. X equals plus or minus the square root of 8 equals plus or minus 2 multiplied by the square root of 2. The solutions are 2 square root of 2 and negative 2 square root of 2. Example 7. Solving a quadratic equation using the square root property. Solve the quadratic equation 4x squared plus 1 equals 7. Solution. First, isolate the x squared term, then take the square root of both sides. 4x squared plus 1 equals 7. 4x squared equals 6. X squared equals 6/4. X equals plus or minus the square root of 6 over 2. The solutions are the square root of 6 over 2 and negative square root of 6 over 2. Completing the square. Not all quadratic equations can be factored or can be solved in their original form using the square root property. In these cases, we may use a method for solving a quadratic equation known as completing the square. Using this method, we add or subtract terms to both sides of the equation until we have a perfect square trinomial on one side of the equal sign. We then apply the square root property. To complete the square, the leading coefficient a must equal 1. If it does not, then divide the entire equation by a. Then we can use the following procedures to solve a quadratic equation by completing the square. We will use the example x squared plus 4x plus 1 equals 0 to illustrate each step. 1. Given a quadratic equation that cannot be factored and with a equals 1, first add or subtract the constant term to the right side of the equal sign. 2. Multiply the b term by half and square it. 3. Add half b to the second power to both sides of the equal sign and simplify the right side. And then 4, the left side of the equation can now be factored as a perfect square. 5, use the square root property and solve. And 6, the solutions are negative 2 plus square root of 3 and negative 2 minus the square root of 3. Example 8. Solving a quadratic by completing the square. Solve the quadratic equation by completing the square. X squared minus 3x minus 5 equals 0. Solution. First, move the constant term to the right side of the equal sign, then take half of the b term and square it, and the result to both sides of the equal sign, and factor the left side as a perfect square and simplify the right side. Use the square root property and solve. The solutions are 3 plus square root of 29 over 2 and 3 minus the square root of 29 over 2. Using the quadratic formula. The fourth method of solving a quadratic equation is by using the quadratic formula, a formula that will solve all quadratic equations. Although the quadratic formula works on any quadratic equation in standard form, it is easy to make errors in substituting the values into the formula. Pay close attention when substituting and use parentheses when inserting a negative number. We can derive the quadratic formula by completing the square. We will assume that the leading coefficient is positive. If it is negative, we can multiply the equation by -1 and obtain a positive a. Given ax squared plus bx plus c equals 0, a does not equal 0, we will complete the square as follows. 1. First, move the constant term to the right side of the equal sign. 2. As we want the leading coefficient to equal 1, divide through by a. 3. Find half of the middle term and add 1b over 2a squared equals b squared over 4a squared to both sides of the equal sign. 4. Next, write the left side as a perfect square. Find the common denominator of the right side and write it as a single fraction. 5. Now use the square root property, which gives. And 6. Finally add negative b over 2a to both sides of the equation and combine the terms on the right side. Thus, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula, written in standard form, ax squared plus bx plus c equals 0. Any quadratic equation can be solved using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are real numbers and a does not equal 0. How to? Given a quadratic equation, solve it using the quadratic formula. 1. Make sure the equation is in standard form, ax squared plus bx plus c equals 0. 2. Make note of any of the values of the coefficients and constant terms, a, b, and c. 3. Carefully substitute the values noted in step 2 into the equation to avoid needless errors. Use parentheses around each number input into the formula. And 4. Calculate and solve. Example 9. Solve the quadratic equation using the quadratic formula. Solve the quadratic equation. X squared plus 5x plus 1 equals 0. Example 10. Solving a quadratic equation with the quadratic formula. Use the quadratic formula to solve x squared plus x plus 2 equals 0. First, we identify the coefficients. A equals -1, b equals 1, and c equals 2. Substitute these values into the quadratic formula. The discriminant. The quadratic formula not only generates the solutions to a quadratic equation, it tells us about the nature of the solutions when we consider the discriminant, or the expression under the radical, b squared minus 4ac. The discriminant tells us whether the solutions are real numbers or complex numbers and how many solutions of each type to expect. Table 1 relates the value of the discriminant to the solution of a quadratic equation. Value of discriminant. B squared minus 4ac equals 0. The result is one rational solution, double solution. Value of a discriminant, b squared minus 4ac is greater than 0, is a perfect square. The results are two rational solutions. Value of a discriminant, b squared minus 4ac greater than 0, not a perfect square. The results are two irrational solutions. And value of a discriminant, b squared minus 4ac less than 0. The results are two complex solutions. That is table 1. The discriminant definition. For ax squared plus bx plus c equals 0, where a, b, and c are real numbers, the discriminant is the expression under the radical in the quadratic formula, b squared minus 4ac. It tells us whether the solutions are real numbers or complex numbers and how many solutions of each type to expect. Using the Pythagorean theorem. One of the most famous formulas in mathematics is the Pythagorean theorem. It is based on a right triangle and states the relationship among the lengths of sides as a squared plus b squared equals c squared, where a and b refer to the legs of a right triangle adjacent to the 90-degree angle and c refers to the hypotenuse. It has immeasurable uses in architecture, engineering, the sciences, geometry, trigonometry, and algebra, and in everyday applications. We use the Pythagorean theorem to solve for the length of one side of a triangle when we have the lengths of the other two, because each of the terms is squared in the theorem. When we are solving for a side of a triangle, we have a quadratic equation. We can use the methods for solving quadratic equations that we learned in this section to solve for the missing side. The Pythagorean theorem is given as a squared plus b squared equals c squared, where a and b refer to the legs of a right triangle adjacent to the 90-degree angle, and c refers to the hypotenuse as shown in figure 4. 2.5